Hello everyone, Namaskar, welcome to Maths Guidance and welcome to the concluding video lecture of this chapter number 10. This is going to be lecture number 6, okay, of chapter 10, that is circles. And in this lecture, this is going to be the question answer session. We are going to solve some very good questions related with the topics which we have studied for the last few days. But let me remind you the theorems. Let us recap the theorems which we have studied in this chapter, because there are so many theorems, and without the knowledge of those theorems, the question solving is not a good practice. All right, so better first you know all the theorems. Let's revise it, and then you will understand the solution in a very good way. So to start with, the first theorem which we had studied was equal chords of a circle subtends equal angles at the center. All right, when the chords are equal, then the angles subtended by these chords are also equal. And the second one which we had studied was the converse of this theorem, that if the angles subtended by the chords of a circle at the center are equal, then the chords are also equal. Now the third theorem was related with the perpendicular from the center of a chord, center to a chord. So the theorem was like this: the perpendicular from the center of the circle to a chord actually bisects the chord. Alright. Now the fourth one was the converse of the theorem, that if the line drawn through the center of a circle to bisect a chord, line drawn through the center of a circle to bisect a chord is actually perpendicular to the chord. Then we came to know that there is one and only one circle passing through three given non-collinear points. That is, there is a unique circle passing through three non-collinear points. Its proof we have also gone through. Then we came to the chords and their distances from the center, and under this topic we studied that equal chords of a circle are actually equidistant from the center. That means from the distance from the center to the chord, that perpendicular distance is equal. Alright, if the chords are equal. Then we moved on to angle subtended by arc of a circle, and under this topic we went through a very important theorem, that was the angle subtended by an arc at the center is actually double the angle subtended by it at any other point. And we have solved some very good questions related with this theorem. The next one was the angles in the same segment of a circle are equal. This is also very important theorem. Angles in the same segment are equal. All right, and its corollary, you can say that angle in a semicircle is a right angle. Then one more theorem we studied, that was the if a line segment joining two points subtends equal angles at two other points lying on the same side of the line containing the line segment, then the 4 points lie on a circle, that is, they are concyclic. This was the converse of the theorem, angles in the same segment of a circle are equal. Alright, then we came to the topic cyclic quadrilaterals, and under this cyclic quadrilaterals, the only that very unique property, that the sum of either pair of the opposite angles of a cyclic quadrilateral is 180 degree, that is supplementary. Alright, and we have seen its proof also. Then obviously its converse is also true, that if a pair of opposite angles of a quadrilateral is supplementary, then the quadrilateral is cyclic. Now we have revised all the theorems. Now let's come to the question solving part, and it's going to be very interesting. We are going to solve some 5 or 6 questions. I hope you will enjoy the video, you will enjoy the topic. All right, and thanks for giving the time. Thank you very much. So friends, let's start the video with this question. The question is like this: in the given figure, A, B, C and D are 4 points on a circle. A, B, C and D are 4 points on a circle. AC and BD intersect at a point E. Alright, these are the AC and BD intersect at point E, and it is making an angle of 130 degree here at point E. Angle BEC equal to 130 degree, and angle ECD equal to 20 degree. Angle ECD, it is given 20 degree. We have to find angle BAC. Okay. So if you observe this figure, you can observe that this angle BAC and this angle BDC, BAC and BDC, they are on the same segment. Alright, so we have studied this theorem that angles in the same segment are equal. So this angle BAC equal to angle BDC. So first of all, let's write it: angle BAC equal to angle BDC, and you have to write it here that angles in the same segment are equal. angles in the same segment are equal. Same segment are equal. Now why I am writing this first of all, because our we have to find this angle BAC, but we will not concentrate on finding this. We will concentrate on finding this one. All right, because if you find this one, then same angle is this, and this is easy to find. See, in this triangle CDE, this angle is given 20 degree. This angle we can find from here. This is making a linear pair, so very easy to find this one. So first of all, let's find this angle. So angle BEC plus CED, we can write angle BEC plus angle CED, that is equal to 180 degree, because it's a linear pair. Okay, from linear pair axiom you can say these two angles add up to 180 degree. This implies angle CED is equal to 180 degree minus 130 degree, that is equal to 50 degree. Now this angle is 50 degree, this angle is 20, so this is easily you can find. Now we will do in triangle CDE. So this angle CED plus angle ECD plus angle CDE, that is equal to 180 degree, we can write, which is angle sum property of a triangle. Angle sum property of a triangle. Alright, this implies this CED is 50 degree plus ECD is 20 degree given, plus this one we have to find CDE, that is equal to 180 degree. This implies angle CDE is equal to 180 minus 50 plus 20, and 180 minus 70, that is 110 degree. Hence angle, this angle 110 degree, so this angle is also 110 degree. Angle BAC is equal to 110 degree, and this is the answer. Angle BAC we have to find angle BAC, so this is 110 degree. So it was a simple question. Now let's move on to different question, second one. Now the second question which I have taken is this one. In the given figure, angle PQR equal to 100 degree, PQR 100 degree, where PQ and R are points on a circle with center O. Alright, PQ are and points and center, this is O. Find angle OPR, means this angle we have to find. Okay, OPR, this angle. So if you see that this angle PQR and this angle OPR, this angle is made at the center and this is at any other point. So we know the theorem that angle at the center, angle subtended, let's write the theorem, angle subtended at the center is double the angle subtended at any other point, double the angle subtended at any other point on a circle, subtended at any other point on a circle, other point on of the circle, subtended by the arc, alright. That means this angle POR is equal to twice angle PQR. But in this case, this angle POR is not equal to PQR. This reflex angle POR is equal to twice of angle, let's write it, reflex angle POR, because this is the major arc. Alright, so we will write reflex angle POR, that means this angle is actually double this angle, so that will be equal to 2 into 100, that is equal to 200 degree. Now this reflex angle is 200 degree, so we will find this angle POR, angle POR equal to 360 degree minus reflex angle POR, reflex angle POR. Okay, So that is equal to 360 degree minus 200 degree, that is equal to 160 degree. So basically this angle equal to 160 degree. Now in triangle POR, you can see this is the center of the circle and these two are radii. So OP equal to OR, that means this angle is equal to this angle. So angle OPR is equal to angle ORP, because angles opposite to equal sides are equal. Angles opposite to equal sides are equal. This is the theorem which we have studied in the earlier chapter. Now if you see in this triangle OPR, this is 160 degree and these two we have to find. Therefore angle, the central angle POR plus angle OPR plus angle ORP, that is equal to 180 degree. That is angle sum property. Angle sum property. Alright. This implies angle POR is 160 degree plus twice angle OPR we can write, that is equal to 180 degree. This implies twice angle OPR equal to 180 minus 160, that is equal to 20 degree. This implies angle OPR is equal to 10 degree. And this is the answer. We have to find this angle OPR. So this angle and this angle basically both are same and both are equal to 10 degree. Alright. So 10 degree is the answer. Okay. So we are using this theorem. Angle subtended by the arc at the center is double the angle subtended by it at any other point of the circle. Alright. And this is the case of reflex angle. You have to keep in mind always. If you do this angle 200 degree, then everything will be problematic. And this cannot be 200 degree because angle sum property says that all the angles add up to 180 degree. So this cannot be 200 degree. This reflex angle is 200 degree. Then we found that this is 160 degree and then we used this one, angles opposite to equal sides are equal. Alright. And this way we have solved this problem. Okay. Now let's move on to third question. Now this is the third question which I have taken. If the non-parallel sides of a trapezium are equal, prove that it is cyclic. Alright. So let's draw a trapezium first of all, like this way. Okay. Let's name it A, B, C and D. So these two sides are equal. Non-parallel sides are equal. And we have to prove that this is going to be a cyclic quadrilateral. Okay. So first of all we'll write that what is given. Given is AD is equal to BC. This is given. Alright. Now we will do one construction like this. We will draw a perpendicular here and we will draw a perpendicular here. Okay. Let's name it AM and BN. So let's draw perpendiculars. Let's draw perpendiculars AM and BN to the side CD. To the side CD. Alright. So this is 90 degree perpendicular. Now what we will do, we will prove that these two triangles are congruent. So in triangles AMD and ANC, we have what we have AMD and ANC. This AM equal to BN. Why? Because this is the distance between the parallel lines and this is going to be equal. Distance between the parallel lines. This is going to be equal always. The parallel lines. Okay. Second one, AD is equal to BC. AD is equal to BC. It is given. Okay. Now the third one is this angle. Angle AMD equal to angle ANC. This is 90 degree. So by the RHS, congruence rule by RHS. Right angle, hypotenuse and side congruence rule. We can say that these two triangles are congruent. Triangle AMD is congruent to triangle ANC. Now what are we going to achieve by doing this, these two triangles congruent? We will achieve this angle is equal to this angle. Therefore angle D is equal to angle C. You can directly write by CPCT. Now since angle D is equal to angle C have been proved, now let us come to here. Let's extend this like this. These two are parallel lines and this is a transversal. Alright. So this angle plus this angle, this angle is equal to this angle. Now this angle plus this angle 180, that means this plus this is equal to 180. That means A plus D equal to 180. Now let's write it. Now AB is parallel to CD and AD is the transversal. We can directly write that this angle A plus angle D equal to 180 degree. Angle A plus angle D is equal to 180. This is the property of lines. That these two angles are supplementary. This implies angle D equal to angle C. That means we will put in place of D angle C. Okay, so that angle A plus angle C is equal to 180 degree. Now you see angle A plus angle C equal to 180 degree. Similarly, you can draw this second one, angle B plus angle D is equal to 180 degree. That means what? That means this cyclic is quadrilateral. That means this quadrilateral is cyclic ABCD. This means trapezium ABCD is cyclic quadrilateral. Trapezium ABCD is a cyclic quadrilateral because of the converse of the theorem that the opposite angles are supplementary in a cyclic quadrilateral. Okay, so this is proved. So first of all we have drawn two perpendiculars AM and BN, and then we have proved that these two triangles are congruent. After proving these two triangles congruent, we came to the conclusion that this angle D equal to angle C by CPCT. Now this angle D plus angle A equal to 180 degree, this is the property of the lines. Now putting angle C in place of angle D, so angle A plus angle C equal to 180 degree, and similarly taking this line you can prove that angle B plus angle D equal to 180 degree, and from the converse of the theorem this is a cyclic quadrilateral. Alright, now let's move on. Let's see the fourth question. The fourth question is, if a line intersects two concentric circles with the same center, with center O at A, B, C and D, prove that AB equal to CD. That means these are the two concentric circles having center O, and a line intersects. This line intersects the two circles at A, B, C and D, 4 points. We have to prove that AB is equal to CD. Alright. So before solving this question, let us write the one theorem, that the perpendicular from the center of a circle, the perpendicular from the center of a circle, to a chord bisects the chord. Okay, we have gone through this theorem. The perpendicular from the center of a circle to a chord actually bisects the chord. So we will draw a perpendicular here like this. Okay, now let us suppose this is point M. Now this inner circle, the chord of the inner circle is BC. Now this perpendicular will bisect this chord. So first of all we will write BM equal to CM from first circle, from inner circle you can write from inner circle, and using this theorem. Okay, now the second thing we can write AM equal to DM, from outer circle. all right, from outer circle. Now this is 1, this is 2. If you subtract 1 from 2, now subtracting, let us write it, subtracting, since these two equations are equal, so we can subtracting equation 1 from equation 2, we get, what we get, am minus bm is equal to dm minus cm. Okay, so am minus bm, that means what? That means ab, and dm minus cm, that means what? That means cd. This implies ab is equal to cd. This is what we have to prove. Now this is proved. Okay, this we can do, we can subtract this thing, equals from equals. Okay, so the question is like this. We are using this theorem. The perpendicular from the center of a circle to a chord actually bisects the chord. Alright, so that is why the theorems are important. We have to know the theorems, otherwise solving the problems will become problematic. So bm equal to cm, am equal to dm. Now we subtract equation 1 from 2 and we will get this one. So ab equal to cd proved. Alright. So friends, we have seen some 4 questions, and all the questions were taken from the NCERT textbook, and I hope that you like the solution. By this way, we have gone through all the theorems which we have studied. This was a recap of all the theorems, and of course the question solving part is very important. So I hope you like the chapter also. Through this video, we are actually able to complete this chapter number 10, that is circles. So from the next video, we will move on to the new chapter. All right. So keep watching my videos, and thanks for giving the time. Thank you very much.